Okay, so in this video we're talking about an important idea called standardizing normal data. Why do we want to standardize it? Because depending on the tests that we use or the sampling techniques that we use to collect our data, not every normal data set or normal curve is going to look exactly the same. So when we standardize our data, everything looks the same. That way we can talk about everything in the exact same mathematical language. So that's what we want to do, is standardize data whenever possible. So the standardizing rule, we have to know the mean, we have to know the standard deviation. Here, x represents one particular data value. As we just saw in the previous video, that some data sets will have millions of data values in it. So you don't want to do this by hand unless you absolutely have to. Most computer programs these days will do this for you. But here's the formula just in case you ever have to do it by hand. We call our standardized data value z. X is our original data value. The Greek letter lowercase mu is still our average, or the mean, and the Greek lowercase letter sigma is still the standard deviation. So let's do a few examples. In this example, we're going to consider a normally distributed data set with mean 45 and standard deviation 10. We're going to use this information to standardize all four of these individual data points. So these data points are coming from a normally distributed data set, but we want to standardize them. That way we can talk about them in the same common general mathematical language that we can with every other normal curve. So the formula again that we're going to be using, z, our standard score, is our original score minus the mean divided by the standard deviation. So for each one of these, I'm going to do it. For instance, I'm going to do the first one in red, just some scratch work. So my first standard score is going to be my 55, which was the score I started with, minus my mean score, which was 45, divided by my standard deviation 10. I'm going to use my calculator. Now, the formula includes parentheses, so you definitely need to include those parentheses. If you don't, it will come out wrong. So 55 minus 45 divided by 10 is 1. Got it? That's my first standard score. My second standard score, we need to calculate it. I'm going to do it in green. Again, my given score was 35 minus my average score divided by my standard deviation. Use calculator. So 35 minus 45 divided by 10 is -1. All right, and my third standard score, calculate it. My given score was 50 minus the average score divided by the standard deviation. And you get 0.5. And then finally, my last standard score, I'll do that one in, say, yellow. So my fourth, well, I thought I had yellow. My fourth standard score was 21.58. That was my given score, minus my average score divided by standard deviation. Use calculator. So 21.58 minus 45 divided by 10. And it's -2.342. Okay, so these are my four standardized scores. Now, why is this useful? How do these standard scores relate? Why is it important? Because when we standardize scores, we're going to have a normal curve. I want to draw a sketch. And for every standardized normal curve, this is once we've gone through this problem for every data point in the data set, then our average value, the mean, is going to always be 0. Each standard deviation is always going to be 1. So here's 1, here's -1. That distance is 1 standard deviation above and below the mean. If we had a standard score of 2, that would mean it's essentially that data point would be 2 standard deviations away from the mean. A standard score of 3 would mean that the data point is 3 standard deviations away from the mean, and so on and so forth. And of course it goes to the left as well. Okay, so let's go plot these points. So here, a standard score of 1 on the normal curve would be here. That's my Z1. A standard score of -1 would be here. That's Z2. A standard score of 0.5 would be somewhere here, in between 0 and 1, so that would be Z3. And then finally, a standard score of -2.342 would be somewhere about right here. That would be my Z4. So again, once you have standard scores, it's very easy to see, based on the mean being 0 and standard deviation being 1, it's very easy to see where those data values fall on the normal curve in relation to the standard deviation and the mean. Let's do another example. So consider we have a normal distribution. Again, we are told our mean is 235.7, and we're also told that our standard deviation is 41.58. This time we want to know the original data value x that corresponds with this standardized data value of z equals -3.45. Okay, well, we're talking about a standardized z value. So let's start off with that formula that had a z in it. So x minus the mean divided by the standard deviation. This time we're going to just plug in what we know and solve for what we don't know. So I know that my z-score, my standardized z value, is -3.45, and that's supposed to be equal to x is what I'm solving for, so leave that x. My mean is 41.58 divided by my standard deviation, or sorry, I put my standard, the mean is 235.7, sorry about that. And my standard deviation is 41.58. Okay, so now we need to solve this equation. This is a 2-step equation. If you struggle with solving equations, just remember the order of operations, but this time we're going in reverse. We're looking for add and subtract, multiply and divide, then exponents, then parentheses come last. Okay, so I'm looking for add and subtract first. I see a subtract sign here, however, it's trapped inside parentheses, so I skip this step. I'm moving up to multiply and divide. I see division. Division cancels out with multiplication, so I'm going to multiply both sides by 41.58. So I have -3.45 times 41.58, and that's equal to x minus 235.7. Now what I want to do is to get x by itself. I don't see any exponents. I don't see any more parentheses, so I start the process over. I'm back to add and subtract. Here's a subtract. To cancel out subtract, I have to use add. So I'm going to add 235.7 to both sides of the equation now. So this is where we're at. So 235.7 minus 3.45 times 41.58 equals x. Okay, so now what I'm going to do is use my calculator, type this in exactly the way it looks. We got lots of decimals and everything, so be sure you enter those in carefully, otherwise it's going to come out wrong. So 235.7 minus 3.45 parentheses 41.58. And I get 92.249. So my original score before it got standardized was 92.249. Now let's say the algebra right here is a little tough for you. As long as you can set up this equation, if you can't do the algebra, you can always graph. Don't forget that. Anytime you see equal, you can graph. y1, all of this in y2. The only thing you have to do to make the graphing work is include these parentheses since you have more than one thing in the top of your fraction. And that's it for this video about standardizing normal data. Hopefully it made sense. If not, please let me know if you got questions. That's it.